Hello and welcome. In this video, we'll explore the concept of surds in mathematics. We'll define what surds are and go through the essential rules for working with them. First, what exactly is a surd? A surd is an irrational root of a rational number. Think of it as a root, like a square root or cube root, that cannot be simplified into a whole number or a terminating / repeating decimal. For instance, the square root of 2, the square root of 5, and the cube root of 7 are all surds because their decimal representations go on forever without repeating. On the other hand, the square root of 4 is not a surd because it simplifies exactly to 2, which is a rational number. Similarly, the square root of 9 simplifies to 3. Now, let's look at the rules for working with surds. Rule 1 is simplifying surds. The goal is to make the number under the root sign as small as possible by factoring out perfect squares. Take the square root of 18. We look for the largest perfect square factor of 18, which is 9. So, we rewrite the square root of 18 as the square root of 9 times 2. Using the multiplication rule for roots, which we'll cover next, this becomes the square root of 9 times the square root of 2. Since the square root of 9 is 3, the simplified form is 3 times the square root of 2. Rule 2 covers addition and subtraction. You can only add or subtract like surds. Like surds are those that have the exact same number under the root sign after simplification. For example, 2 times the square root of 3 plus 5 times the square root of 3 can be combined because they both involve the square root of 3. We simply add the coefficients. 2 plus 5 equals 7. So the result is 7 times the square root of 3. Similarly, 3 times the square root of 2 minus the square root of 2, which is like 1 times the square root of 2, equals 2 times the square root of 2. However, if the surds are different, like 2 times the square root of 2 plus 3 times the square root of 5, they cannot be simplified further by addition. Rule 3 is multiplication. To multiply surds, you multiply the numbers under the root signs together. The general rule is the square root of a times the square root of b equals the square root of a times b. For example, the square root of 2 times the square root of 3 is equal to the square root of 2 times 3, which is the square root of 6. Rule 4 deals with division. Similar to multiplication, you divide the numbers under the root signs. The rule states the square root of a divided by the square root of b is equal to the square root of a divided by b. For instance, the square root of 8 divided by the square root of 2 equals the square root of 8 divided by 2, which is the square root of 4. And since 4 is a perfect square, this simplifies further to 2. Rule 5 is rationalizing the denominator. This process is used to eliminate a surd from the denominator of a fraction. It's often considered standard practice to have a rational number in the denominator. If the denominator is a single surd, like 1 over the square root of 2, you multiply both the numerator and the denominator by that surd. So, we multiply by the square root of 2 over the square root of 2. This gives the square root of 2 in the numerator, and the square root of 2 times the square root of 2, which is 2, in the denominator. The result is the square root of 2 over 2. If the denominator is a binomial containing a surd, like 1 over 2 plus the square root of 3, we multiply the numerator and denominator by the conjugate of the denominator. The conjugate of 2 plus the square root of 3 is 2 minus the square root of 3. Multiplying gives 1 times 2 minus the square root of 3 in the numerator. In the denominator, we have 2 plus the square root of 3 times 2 minus the square root of 3. This is a difference of squares, resulting in 2 squared minus the square root of 3 squared, which is 4 minus 3 equaling 1. So the final simplified expression is just 2 minus the square root of 3. Finally, Rule 6 involves powers. There are 2 key power rules related to surds. First, the square of a square root cancels out the root. The square root of a all squared equals a. For example, the square root of 5 squared is just 5. Second, the square root of a squared is the absolute value of a. We use the absolute value because the square root symbol typically denotes the principal non-negative root. For example, the square root of -3 squared is the square root of 9, which is 3, the absolute value of -3. Let's quickly summarize the key points about surds. Surds are irrational roots like the square root of 2. Simplify surds by factoring out perfect squares. Only add or subtract, like surds, same root part. Multiply or divide surds by multiplying or dividing the numbers under the root. Rationalize denominators to remove surds from the bottom of fractions. Remember the power rules. Square root of a squared is the absolute value of and the square root of a all squared is a. Understanding these rules will help you confidently work with expressions involving surds. Thanks for watching.